Hello, it's Junaid here from Haystack Analytics. In my last video, I covered how you could effectively identify where the bottleneck was in a software development team, specifically by starting with cycle time. Then we're able to drill into, what is the largest component of that. It was review time. And then from that review time, we're able to understand actually, the rework time is taking the most amount of time, and understand the process risks which were actually delaying that. So we're able to go from North Star metric right down to, leading indicators and then to risks to understand where these bottlenecks are. But these bottlenecks are different for every single team. So the approach that you need to take to rectify these bottlenecks, it is different depending on the team, depending on where the bottleneck is. So in this video, I wanted to really take a look at the end-to-end software development lifecycle and understand how we can, understand and fix bottlenecks regardless of where they appear in the pipeline. So here I've got change lead time. So just to recap, change lead time is the 85th percentile time from the first commit to a pull request being released. So, the work actually being available and running in production so a customer can actually use it. And the reason this is important is, of course, the quicker we're able to ship work into the real world, the quicker we are able to get feedback from users to shape the future direction of the product. The quicker we're able to ship stuff as well. We're able to ship in smaller batches, which means that the chances of things going wrong are less. So, so speed and reliability really go hand in hand for most teams. And also it helps our developer, as soon as our developers are able to release things quickly, they get quick satisfaction, and there's less manual process for them, which can cause, burnout and things like that. So this is a really important metric that we want to see trending downward. So let's drill into change lead time here, and let's understand what's going on. So we can see here that change lead time is broken down into three areas. We've got development time, review time, and release time. So let's start with, if we were wanting to identify the bottleneck, we'd want to probably focus on release time here, because this is 39% as opposed to 38% review time and 23% development time. But let's go through each of these in order and really understand how we would fix any potential bottlenecks in each. So in terms of development time for this team, it's actually relatively healthy, 1.15 days. We can see that broken down here. And then if I actually break down here and look at them, we see kind of three outlier pull requests. So I'm just looking at, December 27th, it seemed like, this is a bit of a modern spike. In the recent data, it spiked a bit. So there are three kind of outliers where this is, highlighted as red. But really, when we look at the risks, we see something in common, which is too many cooks. Too many cooks. If we go into the Haystack risks article on the Haystack knowledge base, what we'll find is that too many cooks means the number of pull requests or number of pull requests that had three or more committers. So this is probably a pull request which these are one-off pull requests where someone maybe has potentially not been able to complete the task on their own, had to pass it around, maybe perhaps the work was too big sized originally. And although it doesn't have the, one of them has a large pull request risk on, the other one doesn't. So, we'd probably want to understand why these individual outliers are here. We'd want to, actually go ahead and click into them and really understand what was particularly going on at play here. And we would want to really be able to understand what was going on. But In general, when we talk about development time, really what we're talking about is we're talking about the time from the first commit to the pull request being raised. And, the factors we spoke about, as in, maybe a piece of work is too big sized, maybe it is, maybe it's unclear, those can play a part, but often the thing which is uniquely important about development time is actually the local developer experience. So often after someone has made a commit, they'll want to see what it looks like. Maybe after they share what they look like, maybe someone said, no, we need to make these changes, and maybe, there wasn't enough, maybe things were unclear, but also, maybe it's taking them ages to spin up that local development environment to see what they've done. Maybe their local unit tests, their pre-deployment process is just too bulky, it's taking too much time. Those are things which can often make this development time worse. So in teams where this is maybe 2 or 3 times as bad, what you'd really want to do is you'd really want to understand what that development process looks like for the end developer. So the way I would typically do that is it's often useful, for instance, to often can help to kind of interview individual developers one-on-one, really try and understand actually what's going on, where they feel things are painful for them. You can also do team-wide surveys, and also team retrospectives can often be useful. Of course, you'd want to understand these factors can vary depending on team by team or repository by repository. Review time was one we took a look at in the last video, but let's dive into this here. So we see that review time is made up of 3 things. So from the pull request being made to effectively the first review coming in. What often happens here is that slow build times or slow test times, slow continuous integration tests can often be the thing that really slows people down here. And it can also be processed sometimes. It can also be that a pull request is raised, unclear who to assign it to. So maybe there needs to be a code owners file to really understand who this pull request gets assigned to. Rework time, again, unclear requirements potentially. The other thing I should say is often one of the things that can impact, build times throughout this process, especially, first response time, is often what happens when when tests are flaky. Are they constantly breaking and need to be retested? Maybe if they're a flaky test, maybe even if the tests are too brittle, this can often impact on rework times. If you have a lot of brittle tests and you need to constantly make changes to them to get them to work, that can sometimes also come into that first response time there. Rework time is usually more due to things like unclear requirements, things which are, potentially big changes, or potentially, even lots of technical debt that can really make the code base hard to understand, which means that one developer doesn't understand the unintended effects. Another who's an expert in the code base has to tell them where to look, but again this all looks very, very unclear, as the code isn't easy to read, and so this can sometimes be a good indication that maybe maybe you're relying too heavily on one individual. Maybe you need to look to refactor. And then at the end, idle completion time. Some teams I know have actually eliminated this by automatically merging their pull requests after everyone has approved them, and there's similar workflows like that you can use. Idle completion time, usually at the end, it's usually things like those very last sign-offs and things like that. But in some teams, these can often be this can sometimes be a significant proportion. Usually in those instances, it can be because the developers aren't incentivized to complete what they're doing before moving on to the next thing. It's always best to complete something, then move on to the next thing. It means that your software development lifecycle is, it means that your developers are going to be more focused on one thing. When they're focused on one thing, that thing is usually going to be done better, more reliably, and it will be done quicker because there's none of that cognitive overhead of task switching. And of course, we can then look at these metrics, we can drill in and understand where the risks are, potentially things which contribute to these. And then let's take a look at the final part here of change lead time, which is the release time. So this is the biggest thing for this team. And this is really where we would want to look at deployments, because the thing which impacts release time really is after the pull request is merged, how long does it then take for that to go into production? And the thing which impacts that is how close is it going to be to a release. So let's look at deployments. So we can kind of see here, the week-to-week number of deployments, 5 weeks usually, some weeks, potentially they aren't being done at all, indicates that potentially this isn't a automated deployment pipeline. We can see deployments by the repositories, days since the last deployment as well. And so what this indicates is, we aren't really improving this here. We would potentially actually want to deploy more and more, potentially get things to full continuous integration where something is merged and it is automatically deployed into production. And we can also see the impact of these things on quality, right? So this team here, their change failure rate is trending down. They're in this healthy area already, though, this green healthy range. So what this tells me is really that any work they're really doing here probably isn't, the average recovery time is 14 hours. So it seems to me that they're trying to reduce the change failure rate, but potentially they're doing this. What often matters more is actually being able to address these issues quicker. So if you're able to deploy quicker, if you get that release pipeline faster, actually you're able to bring down the time to recovery, which can often be more important than the change failure rate. But this can be something that's useful to keep an eye on. But really, if the team here was able to automate their deployment process, make it less liable to human error, and allow these, allow this to pretty much happen. Someone merges in a change, automatic deployment, that would effectively reduce the level of stress. It would also make things more reliable as they'd be deploying in smaller pieces. So really, those are some critical metrics that are really important to understand here. And with that, we kind of see the entire software development lifecycle from development time through to release, and we can really understand how we can make improvements here. Any questions, reach out to us, support@usehaystack.io, and we're also on the Slack community if there is any other questions you've got. Thanks for watching. See you later.